A very good day to Dr. Maglan and everyone. So today my group and I will present our second group project, which is travel motivation destination image and extreme event using the SmartPLS and SPSS. So our study is to investigate the relationships between travel motivation and destination image while examining whether the extreme events moderate these relationships. So this analysis consisted of three main stages, which is the descriptive analysis using the SPSS, exploratory factors analysis, measurements and structural model assessment using SmartPLS. So I will first demonstrate the descriptive analysis using SPSS. And next, which is analyze descriptive statistics, frequency, move all the main purpose, frequency of travel purpose, and click OK. Okay, so we can see the output, which is this SPSS generates the frequency distributions, percentage and cumulative percentage of each demographic variable. These outputs provide an overview of respondent characteristic before further multi-level analysis.
Now I will continue with the exploratory factor analysis. We first need to press analysis, then go to dimension reduction and choose factor. Now we need to move all the MOT items to extraction, and we need to choose the method of principal components and change the number of fixed factors to number 2. After extraction, we need to move to rotation, and we need to choose the method of PROMAX and continue on to the next step. Next, I will demonstrate the factor score. We first need to choose the method of Bartlett's test. This is the KMO and Bartlett's test. The KMO value is 0.932, which exceeds the recommended value of 0.60. Bartlett's test is significant with p-value below 0.001, indicating that the data are suitable for factor analysis. Now, total variance is explained. The two components were extracted, and together they explain approximately 64.17% of the total variance, indicating satisfactory construct representation.
This is the beta matrix. The beta matrix shows that all 13 travel motivation items loaded onto two distinct factors. Factor 1 consists of MOT 6 until MOT 13. We label this factor as adventure and discovery motifs because these items focus on explorations, discovery, and adventurous experience. Factor 2 consists of MOT 1 until MOT 5 and MOT 7. This factor was labeled as a cultural and social motifs because the items represent cultural, people, and social interactions. No problematic cross-loading were found, indicating a good construct validity.
Next, the SmartPLS measurement model. We first assess the measurement model by examining indicator reliability. Most indicators here exceeded the recommended loading value of 0.708. This indicates that the observed variables reliably measure their respective latent constructs. Indicators with slightly lower loadings were retained because the construct reliability and AVE remained acceptable. So for the cross-loading, each indicator loads highest on its intended construct, demonstrating satisfactory discriminant validity through cross-loadings.
My name is NURADAWIYAH and I'll be presenting about the reliability and validity assessment of the measurement model. First, we evaluated construct reliability using Cronbach alpha and composite reliability. And all Cronbach alpha values range from approximately 0.86 to 0.96, which are above the recommended threshold of 0.70. Similarly, all composite reliability values exceed 0.70, indicating strong internal consistency among the measurement items. Next, we assessed convergent validity using the average variance extracted, or AVE. All AVE values are above 0.50, ranging from approximately 0.55 to 0.89. This indicates that each construct explains more than 50% of the variance in its indicators. Therefore, the results confirm that the measurement model has satisfactory reliability and conversion validity. Next, we assess discriminant validity using the heterotrait, monotrait ratio or HTMT. Discriminant validity is important because it determines whether different constructs are truly measuring different concepts. Generally, HTMT values below 0.90 indicate acceptable discriminant validity. From the matrix, most HTMT values are below the recommended threshold, suggesting that the constructs are empirically distinct from one another. However, a few values slightly exceed the threshold. This is likely because some constructs are conceptually related and may share similar characteristics. Overall, the HTMT results indicate acceptable discriminant validity for measurement model. Thank you. That's all from me.
Finally, we evaluated the structural model using bootstrapping. The relationship between travel motivation and destination image is significant. The fat coefficient is positive with beta value is 0.278, t-value is 4.025, and for the p-value lower than 0.001, indicating that higher travel motivation leads to a more positive destination image. However, the direct effect of extreme event on destination image is not significant. More importantly, the interaction effect between extreme event and travel motivation is also not significant, indicating that extreme event do not moderate the relationship between travel motivation and destination image. In conclusion, the descriptive analysis successfully profiled the respondent. Exploratory factor analysis confirmed that two dimensions of travel motivation. The SmartPLS measurement model demonstrates acceptable reliability and validity. Finally, the structural model showed that travel motivation significantly influenced destination image, while extreme events did not exhibit a significant moderating effect.